Dear students, today we are going to learn about work, energy and power, which is the unit 7 of the grade 8 physics syllabus. So, the topics for today are forms of energy, work done, kinetic energy, gravitational potential energy, interchange of kinetic and potential energy, and power. So, we are going to study about the forms of energy, which are heat, light, sound, electrical, chemical, kinetic, and gravitational potential energy. Then we will see what is work done. That is, work done is equal to force multiplied by distance. Moreover, we are going to study about kinetic energy, which is energy possessed by moving bodies. After that, we will see what is gravitational potential energy, which is energy possessed by a body which is kept above the ground. Moreover, we are going to study the interchange of kinetic and potential energies. So, potential energy can be converted into kinetic energy. For example, a ball released from a height above the ground. As the ball moves downwards, its potential energy is converted into kinetic energy. Finally, we are going to study what is power. So the work that is done in each second is called power. Now let us study the forms of energy in more details. The burning charcoal gives heat energy. The torch that is lit gives light energy. The bell produces sound energy. Here we can see electrical energy being transported from one place to another. The cells store chemical energy. The aeroplane has kinetic energy. The person who is climbing the stairs has gravitational potential energy. So these are the forms of energy, that is heat, light, sound, electrical, chemical, kinetic, and gravitational potential energy. So what is work done? As you can see in the picture, the person is pushing on the table. So the person is applying a force, and the table moves in the direction of the force. It moves through a certain distance. So if we take the force, we multiply it by the distance moved by the body in the direction of the force, we get the work done. The unit of work done is same as energy. It is the joule. Let us see an example. A football player kicks a ball with a force of 500 newtons while his foot is in contact with the ball. It moves a distance of 0.1 meter. calculate the work done by the football player. So we know that work done is equal to force times distance. So it will be equal to 500 multiplied by 0.1, which gives 50 joules. So the work done is 500 times 0.1 is equal to 50 joules. Now let us see what is kinetic energy. We have an object of mass m, which is moving with a speed v. Then its kinetic energy is calculated using the formula. Kinetic energy is equal to half times the mass times the speed squared. So consider the truck, which is having a mass m and which is moving with a velocity v. So we get its kinetic energy as half mv squared. Now consider the example given. A player serves a volleyball with a mass of 0.2 kilograms. The ball leaves her hand with a speed of 30 meters per second. Calculate the kinetic energy of the volleyball. So we know the mass of the ball is 0.2 kilogram. The speed of the volleyball is 30 meters per second. Now using kinetic energy of the volleyball is equal to half mv squared. We get half times 0.2 times 30 times 30, which gives 0.1 times 900, which in turn gives 90 joules. So the kinetic energy of the volleyball is 90 joules. Now, if you look at the truck, will the kinetic energy of the truck be more than the volleyball? Think about it. Now let us see what is gravitational potential energy. The gravitational potential energy possessed by an object is calculated using the equation. Gravitational potential energy is equal to mass times acceleration due to gravity times the height through which the object has been raised. So this gives Gp is equal to mgh. But we know that the weight is equal to mg. Therefore, the gravitational potential energy can also be obtained by multiplying the weight of an object by the height through which it has been raised above the ground. So m is the mass in kilograms, g is the acceleration due to gravity, which is 10 meters per second squared on the earth, and h is the height of the body above the ground. Now consider the example given below. A 36 kilogram girl walks to the top of stairs that are 2.0 meters high. How much gravitational potential energy does the girl gain? So we know that EP is equal to mgh. So it gives 36 times 10 times 2, which is equal to 360 times 2, which gives 720 joules. Now, what would happen if the same girl walks to the top of the stairs that are 3.0 meters high? Will the gravitational potential energy be more, same, or less than the calculated value? Think about it. Now let us see what happens when we are going to roll a marble down the ramp. So what is the form of energy possessed by the marble at the top of the ramp? Since it is at the top of the ramp and certainly above the ground, it has gravitational potential energy. When it is released from the top of the ramp, it starts rolling down. When it reaches at the bottom, it moves away at a high speed. So how the energy at the top has been converted or transformed? So the gravitational potential energy at the top of the ramp is converted into kinetic energy as the ball comes down the ramp. So we can say simply, the gravitational potential energy has been transformed into kinetic energy. Now imagine we take the marble and roll it towards the ramp. What energy conversion would we expect? So while the marble is moving towards the ramp, it has kinetic energy, and as it starts moving upwards on the ramp, it will have gravitational potential energy. So the energy conversion is kinetic energy into gravitational potential energy. So this is a very simple example of how energy can be transformed from one form to another. Now let us see what is power. Power is defined as the rate of doing work. It is also defined as the work done per unit time. So how do we calculate power? Power is the work done divided by the time taken. So consider a crane which is being used to lift a load of 200 kilograms from the ground to a height of 20 meters in 10 seconds. Calculate the power of the crane. So first we have to find out the work done, which is equal to the weight times height, which is also equal to mgh. So work done is equal to 200 times 10 times 20, which gives 2000 times 20, which gives 40,000 joules. So the power is the work done divided by the time taken, which gives 40,000 divided by 10. So the power is 4,000 watts. The unit of power is watt. So let us summarize. We have talked about work done, which is obtained by force multiplied by distance. We have talked about kinetic energy, which is given by half times mass times velocity squared. We have talked about the gravitational potential energy, which is obtained by mass times acceleration due to gravity times height, or weight times height. And we have also talked about power, which is the rate of doing work, or simply the work done per unit time. Thank you for your attention. We are going to have more PowerPoint presentations on the topics that are left. Thank you.